we start this lab, here's proof of my approval to submit this makeup lab. With the pre-lab, using the nodal analysis, we're able to calculate VA and VB on this voltage divider. VA is 3.33 volts and VB is 1.67. For question 2, the error in this code is over here where we're using /t instead of a comma. We should use a comma because the Arduino is sending two numbers separated by a comma. And then lastly, the radius for this ellipse is 5 because the 10 and the 10 in this ellipse function are the width and the height of the ellipse, which in this case it's symmetrical, so it's a circle. So using the Arduino code provided to us for exercise 1, I have two potentiometers. They're wired to 5 volts and ground, and they're being read by analog pins 4 and 5 on the Arduino. Then for exercise 2, we have digital pins 2, 3, 4, and 5 that are going to correspond to up, down, left, right movements when it comes to that exercise. So here's the processing code that was provided to us for exercise 1. Pretty much the analog pins on the Arduino are reading the voltages on the potentiometers, and as those change, that translates to X and Y movement on the screen. So it's also creating a red dot with a diameter of 8. Question 2 for exercise 1, I changed the fill color of the circle to blue by changing this value and this value, and then changing the shape from ellipse to rectangle. We can run this and see what that looks like. Okay, moving on to question 3 of exercise 1, I added these lines of code. Pretty much it tells me how close the dot is to the nearest horizontal and vertical edges, which then I use these if statements to say if it's within 5 pixels of an edge to constrain it horizontally, and if it's within 2.5 pixels to the top, constrain it horizontally. So let's run the code. And you can see it's not gonna escape the screen. And for question 4, I have these for loops that are basically going to increment the blue proportionality when we move in Y. So it gets more blue as you move down, and then these lines are incrementing the amount of red and green as X increases. So it gives a yellow tinge when you move to the right side of the screen. And then this is going to fill the color based off the for loops. So let's run it. So you can see the color changing as we move in X and Y. And for question 5 of exercise 1, pretty much we're no longer going to be able to control X because that's going to be a function of time. With each increment of t, which starts at 0, it's going to correspond to 50 milliseconds, but the movement in Y should still be able to be controlled by the potentiometer. So yeah. And lastly, for exercise 2, I have digital pins 2, 3, 4, and 5 all as inputs. Basically, it's going to read voltages and send those as a string to the processing 10 times a second. And then in my processing code, I'm basically saying if we detect a voltage on some of these, we're going to do some movement, whether that's up, left, right, or down. So I'm also going to put my UID in the top left corner. And then we have these if statements that check if the two dots are going to overlap, and in the beginning we define where those dots are, and then we have a randomizing function that's going to change where those lay on the X and Y coordinates. We also uploaded a PNG, and yeah, let's test this out. So it's over there. Let's move this pin to over there. Yep. And we can also move down to and up. We can test this again. Let's go down. Let's go right. There we are. All right, thanks.